Hello everyone. Now I'll be giving a presentation on research paper What Goes Around Comes Around. This research paper is written by Michael Stonebreaker and Joseph M. Hellerstein. I'm Narendra Bandaru and I'll be continuing this presentation from now on. The topics that are covered in this presentation. So I have covered introduction stating the problem and the evaluation of the data models and the explanation of the problem and why is it challenging the problem and the limitations of the related work, contributions of the paper by the author, and the methodology. So I'll be discussing in detail in the further slides about all these topics. So firstly we'll be discussing about introduction stating the problem. This paper addresses the issue of 35-year cycle of repeated suggestions for data models. It talks about how most new ideas for data models are very similar to the previous ones, and how this reinvention trend has continued across many database management systems architecture periods. This paper clearly states that there are very few fundamental concepts in data modeling and that new proposals usually have a lot in common with some of the older ones. The significance of this issue has also made evident with a focus on the necessity of knowing the background of these models in order to prevent making the same mistakes twice. However, the primary proposal of the modern XML period is quite similar to the early 1970s Committee on Data System Languages plan, which was unsuccessful due to its complexity. Thus, history is being repeated in the present era. Now we'll be discussing about the evolution of data models. So the author has clearly stated all the data models and has explained very clearly in the paper each model. So firstly we have hierarchical, which was used in late 1960s and 70s, and then we have a network which is used in 1970s, and then relational in 1970s and early 1980s, and then we have entity relationship in 1970s and extended relational in 1980s and semantic in late 1970s and 1980s and object oriented in late 1980s and early 1990s and object relational, which is used in late 1980 and then early 1990s, and then semi-structured, which is also called as XML. It's used in late 1990s to the present. And then here we'll be discussing about the explanation of the problem. So this study tackles a noteworthy and pertinent issue within the domain of database management systems in order to help future researchers avoid making the same mistakes and complications that have been made in the past. The paper examines all the historical trends of data model suggestions. The study makes the case that more effective and user-friendly data models can be created by understanding the development and recurrent themes in data model proposals. This is especially important in light of papers finding that simple model typically provides superior logical and physical data independence and that complicated models like the Committee on Data Systems Language or IMS Logical Database have traditionally failed. The problem is not new, but the paper's approach to summarizing 35 years old of data model proposals and deriving lessons from each era provides a fresh perspective on long-standing issues in DBMS. The paper emphasizes the importance of simple, understandable, and efficient data models, the influence of market forces on the adoption of technology, and the potential pitfalls of complexity, which can repeat historical failures if not acknowledged and addressed. Now we'll be discussing about why is it challenging. So why this particular topic of the evaluation of the data models is challenging. So the study outlines the difficulties in implementing new models in the technology industry as well as the complexity present in different data modeling techniques. And some of the challenges are complexity of logical database, the complexity of IMS logical database, and the difficulty of implementing SQL on top of it due to semantic issues made the extension of the data models challenging. And then technological acceptance. The acceptance of new models is often determined by the market forces rather than inherent technical merits of the model themselves. And performance issues. Even when enhancements to data models are proposed, such as in R++ era or with object-oriented database, they often fail off to offer the significant performance improvements over existing models, which dampens enthusiasm for the adopting new models. Market fragmentation. The failure of object-oriented databases to gain significant market traction despite technical merits illustrates the difficulty of changing entrenched market habits and the preference for established technologies over the new ones, even when the latter may offer advantages. Standards and compatibility. The absence of standards and compatibility among different systems adds to the difficulty. Without agreed upon standards, it is challenging to implement and ensure widespread adoption of new data models. Schema complexity. The paper discusses the complexity of schema evolution and the challenge of moving from rigid schema first approach to more flexible schema last or schema-less models. The novelty in solving this problem does not come from overcoming computational barriers but from successfully integrating the lessons from the past, simplifying data models, and achieving market acceptance for these innovations. Now we'll be discussing about the limitations of the related work. So we'll be discussing about the topics limitation that is solved in the paper, and has the problem ever been solved before, and what's the complexity and the technological complexity. So the paper does not claim to solve these limitations, but provides a historical analysis to illustrate the cyclic nature of the problem and to caution against repeating past mistakes. And has the problem been solved before? The paper suggests that while aspects of the problem have been addressed before, but no definitive solution has been accepted universally. Previous solutions have faced limitations such as complexity, market adoption challenges, and technological shortcomings. Complexity. Many semantic data models were very complex, mostly remaining as theoretical proposals rather than the practical solutions. Technological complexity. The introduction of XML and related technologies such as XML schema and XQuery brought a new level of complexity to data models, incorporating features that were known to be complex and had never been attempted before due to their intricate nature. In this slide, we'll be discussing about the contributions of the paper. Of course, the author has done a very good contribution for this paper in aspects of historical analysis and also in critical evaluation of XML based models. In historical analysis, the authors provide a comprehensive historical analysis of the evolution of data models over 3 decades, which is significant contribution in itself. And the lessons learned, they distill key lessons from the history of data model proposals, which are meant to inform current and future researchers and practitioners in this field. And the critical evaluation of XML based models, the author critically evaluate the current as of the paper's writing trend towards XML based models, pointing out the complexities and potential for repeating past mistakes. And the novelty, the problem addressed by the paper is not new, but the comprehensive retrospective analysis that spans several eras is a novel contribution. And the paper's approach is not an extension of related work, but rather a holistic analysis that seeks to provide insight into the cyclical nature of the problems to not occur in the future. And now we'll be discussing the methodology that is used by the author for this research paper. So this paper employs a historical analysis and critical evaluation approach. It reviews the evolution of data models over several decades, focusing on the key debates, developments, and lessons learned from each era. Comprehensive overview. The methodology provides a thorough and comprehensive overview of the history of data models and giving readers a broad perspective on the field's evolution. Insightful analysis, the critical evaluation of different eras and the lessons learned offer valuable insights, especially regarding the complexities of data models and their market acceptance. Informative for the future research. By understanding the historical context, future researchers and practitioners can learn from past mistakes and success, potentially guiding more effective data model development. In summary, while the paper's methodology offers a valuable historical perspective and critical insights, it does not include empirical validations or analytical evaluations typically found in more experimental or theoretical research. So this slide is all about the references that are used for this particular presentation, and the author has also used all these references for his paper, and this is the link of the paper. What goes around comes around. Just feel free to watch the research paper, and if you have any doubts or any comments, just comment down below. And thanks for watching this presentation.